Hey everyone, I wanted to give an overview of one tool I use to help with my reverse engineering efforts when it comes to mainly to arcade hardware. I have a setup here, also with some streaming stuff set up. Um, this is, I use my MacBook for a lot of stuff just because it's portable, so I can, work on the couch downstairs. I can work up here, and I try to develop workflows that allow me to work almost anywhere. So here's my MacBook. It is connected to this arcade board. Well, to the PicoROMs on this arcade board, and the arcade board's connected to a super gun and into the TV. The most important part is the two PicoROMs here, which are ROM emulators. So I can download software from my Mac onto these and then run them on this board. One of these uses its external reset line is connected to this reset IC, which will allows it to reset the board to toggle power or do anything like that. So I like to build out test ROMs that allow me to test various functionality of the arcade board, see how it behaves with different values. It also makes it easy when you need to like use a logic analyzer or something else to analyze the signals to have something super consistent that you control that you can send through the system. I lucky enough that GCC still has a maintained fork that works with Intel 16-bit architectures because it's not super common these days. You notice use of like far pointers here because it's a segmented architecture. Um, I can this enabled. Let's just run it real quick so we see what happens. So we can make changes here in the code and save. That gets uploaded to the PicoROMs, and then the reset line is triggered, and the new changes take place. So we can change the position of one of these sprites. Let's move it up to line 200. Just hit save, and it moves down. Let me get rid of that white flash at the start. So right at the start here, we set the first color to white, just so it was obvious that something was happening before other things were executed. So let's just set it to black, so when we do save and reload, there's no bright flash messing up the camera. So yeah, we can move some sprites around. Four. This is driven by, make files for the most part. We have a bunch of just setting up source files and different configurations so you can run original ROMs or modified ROMs. We build down here, and then down here is the part that actually controls the Pico ROM. So we set the reset line low, we upload to the CPU high and the CPU low, and then we set the reset line back to high impedance so it's not interfering and the system boots up. We This make file can also just run MAME, which is nice because it means you don't always have to be here with the hardware to test something out. So kind of that portable aspect of it can have the exact same functionality here in MAME. You have debugging if you need it. You can set breakpoints. You can look at different values. You can compare what MAME is doing versus what you're seeing on real hardware. There's also useful tools in MAME like this, like tileset viewer. So we can, if we want to know, oh, what kind of object can we use, or if there's a sprite we can use to like look nicer or move around. Actually, let's look at that. So let's change these. These are three sprites right here. Let's change these to something more interesting. So let's run MAME again so we can look at the object data. And okay, let's get to our sprites. The nice palette. So the 20s and 30s hex here are little Bomberman guys. So let's change that to 20. Let's just start with 1. We might end up with still some objects on screen because I'm not clearing this this kind of sprite memory each time I reboot. Maybe I should just do that. So we can memset object RAM to 0. Let's do 256 Okay, so there is a guy, um, half a guy. Let's give him another half. So let's update this X position, move it over a little bit, and then enable the flip, which is, actually let's look at this object structure real quick. So this is from looking at MAME's data on how it's extracting information out of Sprite RAM. So pretty much all of the bits are accounted for in here, except for about 6 of them that I think are not used, but I used MAME to understand the structure, then built a C structure with bit fields here to make it easy to manipulate in C code. Um, it's not like this is pretty, at least as far as all the different IRM hardware I've seen, this is pretty standard for them. Um, Putting the Y value here first in like the first word of memory means that they can, as soon as you read that value out of the buffer, you can compare it against what the current scan line is and use that to quickly discard whether you actually need to keep reading more sprite data. So like this is enough. This information here, the Y value, the height, and whether it's flipped or not, is enough to tell you whether on this particular scan line you're going to need this to draw the sprite or not. So you can kind of early out if that doesn't match up and not read as much memory. So we have this guy, those flip flags here to flip to like mirror on the x-axis, and the y-axis we're going to mirror this guy on the x-axis and move them over a little bit, and we should get another half. Yeah, okay, there we go. Let's see if we can animate him. Let's make a frame counter. Increment that frame counter each frame. We have a v-blank weight up here, so should be running about 60 FPS. So let's, every 16 frames, let's say, let's change this to 24. I think that was another frame of animation. Let's do the same here, but let's do the opposite here. I think that's right. There. The little walking dude. There he goes. Okay, so there's more uses here than just animating the little guys. Um, you know, this is useful to have a kind of a known data coming in. So when you're doing logic analysis, when you're looking at other things, you can you have like a pretty simple data set focused on what you're interested in. Like one thing I often use this for is ensuring that like sprites and playfields match up between the core and what's on the hardware. Like I can run this stuff in MAME. It's also pretty easy to via like SSH, like copy over these ROMs and run it on a core on the Mister if you have one written. I don't have one written yet for this arcade board. So like you may want to like line up the play fields with the sprites and ensure those are set correctly and that they are the priorities are working correctly between them. So what's drawing on top makes sense. So let's just draw a little box behind this guy. We have this pfsim function that I wrote. I'm going to draw it on the first layer. Let's use color. Let's use the palette 3. We're going to do, I'm not sure where this is on the screen, so we'll start off here. And the symbol, the first like 16 text symbols, like character symbols and IRM stuff is usually just solid colors, which is kind of useful to, you can just kind of pick a color out of the palette using that. That should be it. What do we get? Okay, so we get a box. It's solid on my screen. It looks kind of grainy on the camera. Let let's adjust the position so this is behind our guy. Let's move it over. This is what I really like about this. So you can just tweak values and not worry about some long build time or some other issue. Let's make it a little bit wider. There he is. And let's make it taller and move it up one. And a little bit wider. Okay, so now we have a sprite rendering on top of a tile map. I know that these have, the tiles here have priority flags that go in with the color. If we look at the Playfield header I've wrote, these are the different flags. As far as I'm aware, they can be passed in on each along with color. You can flip X and Y, similar to what you can do with the sprites on the mirroring. And you can also, it has some priority fields that I do not understand fully what they do yet. Does Prio 0 use something? That's still the same. Let's see, 1. I'm going to guess this ends up drawing the Playfield on top of the sprite. Yeah, okay. So he's now hidden behind the Playfield. I'm trying to find a color that's not as offensive on the screen. I'm just going to stick with that one. Like if I move this down a little bit, there. So he is rendering now behind this this playfield. I'm assuming some of those other priority flags maybe control the order of the playfields themselves, which maybe we can test out. Let's. I think I've got a second layer set up, so let's draw on the second layer too. Let's not use any priority right now, and let's offset it a little bit more. So we'll draw it higher up. Okay. So let's change the color on this so we can see the difference between them. Okay, so we have the blue layer. The blue layer is like Playfield 1. The orange layer, orangish amber layer, is Playfield 0. And 1 is drawing behind, and it's drawing behind the sprite. Playfield 0 is drawing in front of Playfield 1 and is drawing in front of the sprite itself. I don't know if we can mess around with these priority flags and see if they do anything else. Let's try 0 on this. No change there. We said 1 on this. Does it draw in front? Yeah, so on 1, that draws in front of the sprite. Let's not set any priority there. Let's set this to give it both Prio 0 and Prio 1. No change. So maybe that Prio 0 just does nothing. Or maybe it interacts in weird ways with certain colors. Is another way sometimes this works, where like the lower 8 colors behave one way with or without the priority flag, and then when you have the priority flag set, these colors behave differently. But like having this, I can quickly run tests here. I can compare them on the core. I can compare them in MAME, make sure like understanding what these different values do. I can look at the alignment between these, like the sprite layer and the tile layer, and confirm that that matches up between MAME, between real hardware, and between the core. So it's a really quick way to explore how the hardware is functioning and quickly pass in values and test something out. Like in some cases with like the M107, like I built a much more elaborate kind of test application that I could like go into different modes and look at different settings and move stuff around. This I don't think I'll need to do that much exploration on because it's not a super complicated system. It's really just like the main thing I need to work out right now is just what is the timing on the reads of this information. Like if we look up here, I have to adjust the playfield positioning to get both playfields to line up correctly. So there's a difference of 4 pixels between playfield 0 and playfield 1. So I know that kind of means there's probably 4 pixel clocks between when it reads the playfield 0 information and when it reads the playfield 1 information. On previous hardware, it was 2 pixel clocks between those. But because this is one chip doing both the playfields and the sprites or the objects, it is probably interleaving those sprite reads with the toggle reads. So in between those two, it's doing some additional reads. Let's get some more guys marching. There we go. One guy's in bed and one guy's up and ready to get his day started. So that is like kind of just a really quick overview of what I sometimes do with this. Again, I can run this stuff in MAME and I can do this anywhere, which is very nice. I don't need to be at my workbench with the hardware doing this. So I can write tests on the couch and then come up here and try them real quick on the hardware and see what else I can explore. So I'm not spending all my time standing here like lining stuff up and deciding which exact color to use or which sprite to use. And that's it. Thanks for watching and paying attention to this.